In this update, I complete all the problems in section 11 that I attempted, of course, and then also, and that's, let me just give us some numbers. So now I'm at 739 problems, which is 43.8% of all the problems in Gallian. I'm at 348 proofs attempted, September 12, 2025. And I've also read section 24. As I mentioned in the previous video, I'm going to jump into all the sections in the back that are all group theory to finish everything group theory in Gallian in one shot, and then get back to 12 and rings after I complete all these sections up here. Okay, so to the book. Now, things got a little happier by the time I got to this point in the problems in section 11, because I had already gone through a couple of tangents in chapter 10 and chapter 11 from what I believe is content that is missing in Gallian. I understand his limitations. He's trying to take what Dumbit and Foote did in 1,000 pages and summarize all that the best that he can, most parts of it, into something that can be covered usually in a semester. I don't believe Gallian is designed for a 2-semester course, so far as I know. And so I get that. So the latter problems got very straightforward once I figured out the whole game of, in some questions you're actually answering how many abelian groups of this order are there, which is a different question to how many homomorphisms are there between this group and that other group, and sometimes in the other direction. So that's a very different problem. And I wish Gallian had even said that in here, and he did not. That kind of threw me for a spin. But in the era of YouTube and so many wonderful videos out there, that actually isn't the big problem that it seems that it could be. Okay, so let's jump to section 24. Then in the case of 24, I read about the Sylow Theorems, which again, in this case also, I'm starting to use Dumbit and Foote more as a reference because it's got so much more content. The content on Sylow Theorems in Dumbit and Foote is gigantic. And so that's great. It's really good that as I'm reading in here, I can always go back and look in Dumbit and Foote and see how this is done. And when you're really blowing it up and showing all kinds of calculational details, which Dumbit and Foote does. And I think I should show that. I wasn't planning to, but I think I should. Just so you get a feel. Okay, just so you get a feel for the difference. Okay, so there are 3 Sylow theorems. Okay, the first one is about groups of order p to the k. The second, then there's Cauchy's theorem, which was also shown before, but now is shown here again. And then there's a second theorem that is about, so if H is a subgroup of G, the power of H, the order of H is a power of a prime P, and, that's an and, then H is inside some Sylow P subgroup. And then, of course, you have to know what a Sylow P subgroup is, which is P to K divides the order of G, and P to K plus 1 does not divide the order of G. Then any subgroup of G of order P to the K is the Sylow P subgroup. So it's all these subgroups of a power of some prime. So for example, if the order is G, 2 to the 3, 3 to the 2, 5 to the 4, 7, consistent with Lagrange's theorem, that order is a P group. So for example, in this particular case, it would be 8, 9, and then 625. Yeah, 625 is a Sylow 5 group subgroup. 8 is a Sylow, the subgroup of order 8, giving it a name, is a Sylow 2 subgroup. And then the third theorem is right here. And this one is more like the count. How many of them are there? And you do 1 mod P, and wherever you find, you do mod P of the prime itself, not the prime to any power, and you do once. And I believe I can show that here. I'm not, yeah, I think so. I think I do have some of that. Yeah, I think I do. All right, so that's the content, and then I'll go to the work itself. Oh, I was going to show Dumbit and Foote. I'm sorry. Lost track of where I was for a second there. Okay, so in the case of the Sylow subgroups in dominant foot, there's tons. So it's right here, section 4.95 and page 139, and you'll see the difference from what I just showed you, that it's a big difference in content. Okay, so here they are, the main theorem. The theorem is actually shown as a single theorem with 3 parts, but these are exactly what I was just showing. The existence of the groups, then the fact that they're contained within some other group, and then that there is a count for them. That is a 1 mod p type of count. And then there's some way in which dominant foot proved the theorem. Yeah. And then the applications is where you'll see that that dominant foot went really further. So there's a lot of calculations, but these are actually included in section 24, but there's more of them in dominant foot than there are in Gallian. Yeah. Okay, so that's what I wanted to show. Then back to the problems. Yeah, so I continue with section 10. And by this time, this really felt good because I had gotten myself out of some trouble, some quicksand, and now I understood what I was doing. Every now and then I could get something wrong, and I understand that happens, but when it came to the calculations, I could do all the orders, figure out which ones were, which specific group was the one that it was isomorphic to. Yeah, these were very straightforward. This was a little difficult. I like the way Gallian did it because it's more like, how many do you have to calculate before you know for sure which one you're in? And I messed it up a little, but I like it. I like this problem. I was close. Yeah, I actually got this right. I thought I got it wrong, but I got it right. And I missed one. I miscalculated one element. You just calculate the orders of all the elements as it was shown before. Yeah. I made a mistake here. This was simple, and I shouldn't have made that mistake. Yeah. The correct answer was better than what I did. Asked for more theorems. Stated more theorems. Yeah, I got close. I was able to lay it out, break out the U groups correctly for the answer. Yeah, so those were the problems. Then I read the section on Sylow theorems. And then for the conjugacy classes, I actually calculated them all, even though the book only calculates a few. I just wanted to do that, wanted to understand. But this was not explained well in the way the equation works, a representative from. It's really, you just pick one and give it a 2. So it's really 1 plus 1, these 1 plus 1, R0 and R8, 180 is 2. And then you pick one each from these other ones. From H, from V, from D prime. From H, from D prime, and from R90 and R270. This was not explained well in Gallian, I believe, and I had to actually go and find a video on the web that explained it. Yeah, this equation. Yeah, from each conjugacy class. I guess he did, and I misunderstood it. Maybe it's my fault, but I had to go get more information to understand. You break out R0 and R180 and you put it here, and then you get the representatives here. And for D4, you get 8 here. And on the other side, you get 1 plus 1 plus 2 plus 2 plus 2. And that's 8. Had to go refresh my memory about orbits because it is used in some of the proofs. I think when I get down to working out problems in section 24, I may actually go and read in detail the proofs in dominant foot because they seemed a little clearer. I didn't do that because I didn't want to take forever to finish this part of the material, but I think I may do that. Yeah, so once I started looking at the examples, at first I was like, he's not explaining it in a way that I can get it. So what I started doing is every time that I read the example, I just lay out all the divisors of the order of the group, then do a mod of each of the primes, And sure enough, once you find the ones, they map exactly to what Gallian is saying in the example. I did it here again as well. And there, and there. Yeah, and there. Every single one, I did not wait for the explanation. I actually calculated it out. And then once I read the explanation, I was like, yeah, right. Good. Felt like I owned it more. Okay, so that's the end of the reading of section 24.